Good morning, students. Today we'll discuss about semiconductor. Semiconductor is a material. It is made up of those having properties in between conductives and in between insulators. Actually, the semiconductor is the most abundant material. It is used for silicon and germanium. And types of semiconductor is material is intrinsic and extrinsic. The best example of semiconductor is gallium and silicon, germanium, gallium arsenide, gallium nitrate. The letter indicates by silicon and germanium. The atomic number of silicon is 14, 10 plus 8 plus 4, 2 plus 8 plus 4, that is valency is 4. That is in between conductors and insulator. That's why semiconductor is preferred for both. What is meant by intrinsic semiconductor? Intrinsic means, what is meant by intrinsic means extremely pure. The pure form is nothing but intrinsic semiconductor. I am asking one question. Semiconductor is extremely pure form. It is true or false? It is true only. Fine. The semiconductor is extremely pure form is called intrinsic semiconductor. What is meant by extrinsic semiconductor? Extrinsic semiconductor is the opposite of intrinsic semiconductor. That is impure form is nothing but extrinsic semiconductor. Now, what is meant by doping? Doping, what is meant by doping? Doping means the process of addition of impurity atoms either from third group of or fourth group of periodic table into pure semiconductor is called doping. Doping means simple terms addition of impurity. Adding impurity is called doping. The exact technical term is adding impurity is called doping. The adding impurity is the underlying keyword. Next, types of intrinsic semiconductor, n-type semiconductor and p-type semiconductor. What is by n-type semiconductor? The semiconductor which are obtained addition of impurity atoms from fifth group into pure semiconductor are called n-type semiconductor. What are the n-type semiconductor? I am asking fifth group or third group and both AB and none. Which one is correct? Fifth group is the correct answer. Next, coming to p-type semiconductor, those semiconductor which are obtained addition of third group. Previously, we discussed about fifth group. Now, third group impurity atoms into pure semiconductor are called p-type semiconductor. Addition of third group impurity atoms provides holes which can accept large number of free electrons. Thus, these materials also called acceptor. The example of p-type semiconductor is aluminum, boron, indium. Here, third group means aluminum valence is 2 plus 8 plus 3. 3 is valence here. That is third. Valence is 3 here. Previously, fifth group means valence phosphorus. Atomic number is 15. That is 2 plus 8 plus 5. 5 is the valence here. Similarly, arsenic, antimony, bismuth is example of n-type. And p-type is aluminum, boron, indium, gallium. Here I will ask one question. P-type semiconductor examples. Boron, phosphorus, antimony, bismuth. Which one is correct? Boron is the correct answer. Again, I am asking n-type semiconductor example is boron, indium, gallium, phosphorus. Which one is correct? Phosphorus is correct. Now we'll talk about application of again diode. Diode simply we can combination of P and N junctions. Okay. Before going to PN junction, we talk about diffusion capacitance. What is meant by diffusion capacitance? Diffusion capacity occurs forward biased PN junction diode. It is also referred to as storage capacitance. It is denoted by CD. The letter diffusion capacitor represented by CD, that is called C suffix D, diffusion capacity. In a forward biased diode, diffusion capacity is much larger than transition capacitance. Hence, diffusion capacitance is considered as forward biased diode. Diffusion capacitance occurs due to storage charge of minority carriers and minority carriers near the depletion region. Then forward bias voltage is applied to the PN junction diode. Electrons in the N region will move into P region. It recombines the holes. In the similar way, the P region will be more into the N region. Recombine with the electrons as a result of width of the depletion is decreases. Here depletion region decreases. Here the electron which across depletion region enters into the P region will becomes minority carriers. The holes which cross depletion region and enter into the N region becomes minority carriers of the N region. The number of charge carriers which come to moves into the another region will be accumulated near the depletion region before they recombine with majority carriers. As a result, the large amount of charge inserted in the both sides of the depletion region. If you see the diagram here, this is positive, and this is the gap is junction, we can call it as, and here this is narrow depletion region is occurred in here forward bias. The depletion region acts as a dielectric or insulator of the capacitor, and the charge stored the both sides of the depletion layer acts like conducting plates of the capacitor. Diffusion capacity is directly proportional to the electric current of the applied voltage. If the charge current flows through the diode, large amount of charge is accumulated near the depletion region. As a result, large diffusion capacitance occurs. In this similar way, the small electric current flows through the diode. Only small amount of charge carrier as a result, large diffusion capacitance occurs. In this similar way, if say small electric current flows through the diode, only small amount of charges occurred here. Hence, without depletion region occurs, diffusion capacitance increases. The diffusion capacitance will be in the range of nanofarads. Nanofarads means 10 into 10 power minus 9. Micro means 10 power minus 6. Suppose let us take formula. The relationship between diffusion capacity is CD equal to dq by dV. Here Q represent charge, V represent voltage here. What is meant by Q means charge and V means different. With respect to derivation, CD is represented as dq by dV. CD is diffusion capacitance, dq is nothing but charge in number of magnetic carriers stored in the outside depletion region, and dV is the change in volt applied across the diode. Next, coming to biasing of a diode. What is meant by biasing? You need to connection power supply is called biasing. Okay, I am representing connection biasing diode. It represent Vf is the forward voltage and R is the resistance. Bias diode, application of extremely voltage source or battery of PN junction diode is called biasing diode. There are two types of biasing diode. One is forward and second is reverse bias. What is meant by forward bias? When the P type of semiconductor connected to the positive terminal of the battery and N type semiconductor with negative terminal of the battery, then PN junction is said to be forward bias. Operation: when the PN junction is forward bias, then holes are replaced by positive terminal of a battery and electrons are replaced by negative terminal of the battery. The force of repletion push holes and electron towards the junction. Taken battery voltage applied is lower than a few number of holes and electron crosses the junction. PN junction with increase in battery voltage, large number of holes and electron recombine with the electrons layer. Thus amount of current flows through the PN junction, that is current increases, and in PN junction with increase of applied voltage and is order of few milliamps. Okay, in the forward bias we current is in the terms of milliamps. Milli means 10 power minus 3. Effect of forward bias: width of the depletion region increases in the forward bias. The width of the depletion region decreases by as whole for barrier potential in PN junction diode width and height of larger decreases allows the more number of holes and electron recombine. Coming to, you see that this block shows reverse bias. Here the positive, this is P side, this is N side, and here P is connected to N side and again N is connected to P side. This is the completely reverse process. This is called reverse bias. Reverse bias means positive terminal of the battery is connected to the P side and negative terminal of the battery is connected to negative terminal, positive of the battery is connected to the N side is called reverse bias. Reverse polarity. If it is N is connected to positive and P is connected to negative, that is called reverse bias. Then the P type semiconductor is connected with negative terminal of the battery and N type semiconductor with the positive terminal of the battery. PN junction diode is suitable for reverse bias mode. When such connection are available, holes are attracted towards the negative terminal and electrons towards the positive terminal of the battery. Majority carriers are drawn away from the junction, which causes increase in the width of the height of the depletion region. Because of the increase in width of the depletion region, holes available in P type and electron in the N type cross the junction. Thus, there no current flow due to the majority carriers in reverse bias condition. However, increased barrier potential helps minority carriers in crossing the junction, which leads the generation of very small amount of current in PN junction. This current is of the order of microamps. Whereas I am asking one question: what is meant by forward bias? The battery of the positive terminal is connected to P side and negative terminal is connected to N side, is called forward bias. Next, what is meant by reverse bias? Same polarity connection or reverse polarity connection, both A and B and none. Which one is correct? Reverse polarity is the correct answer. In the forward bias, the current is in the form of available in milliamps, A bit, B bit is microamps, C bit is both A and B, D bit is none. Which one is correct? Milliamps. Milliamps is the correct answer. Coming to reverse bias, what is, current is in the terms of microamps or milliamps and nanoamps and none. Which one is correct? Microamps. Which in the order of microamps means the depletion regions increases in reverse bias. The comparison of forward bias and reverse bias. When the P-type semiconductor connected to the terminal of the battery and N-type semiconductor connect to the negative terminal of the battery, PN junction is said to be forward bias. When the P-type semiconductor of the battery, N-type terminal of the battery is connected to reverse process, is called reverse bias. Width of the height of the depletion layer decreases with increase of voltage in forward bias. Whereas coming to reverse bias, width and height, the depletion layer increases with increase in voltage. In forward bias current, the current is large in milliamps. Whereas in reverse bias, the current is in the amount of microamps. We already discussed. Next, current flows the forward bias due to majority carriers. In the reverse bias, current flows to the reverse bias due to the minority carrier. In this repulsion force acts. In reverse bias, the attraction force does not act. Forward bias condition, the diode is on, whereas in reverse bias, the diode is off. Okay, this is the difference between reverse bias and forward bias. That's all. And I will ask one question: what is semiconductor best example is silicon, arsenic, bismuth, none. Which one is correct? Silicon is the correct. Atomic number of silicon is 14, 17, 18, 22. Which one is correct? 14. 14 is the correct answer. Most abundant semiconductor material is crystal, carbon, oxygen, silicon. Which one is correct? Silicon is the correct answer. Thank you one and all.